Yeah. Good evening, everyone. So we will wait for some more time till we get the more participant. I think participants are joining. Good evening and good morning, Miss Mousumi. This is Dr. Sandeep from Anurag.
Good evening.
Good evening, and for you, of course, it's a morning. So
Yes, thank you.
yeah. So we will be starting a session in a few minutes, ma'am.
No problem. No
Yeah.
problem.
Yes. Balram sir, can you hear me?
Yes, sir. Yes, sir.
Good evening, everyone. And I will request my colleague G. Balram sir to start the proceeding.
Thank you, sir. Good evening to all. Myself, G. Balram, co-chair, assistant professor, Anurag University, Telangana, India. I welcome you all for the day 2, session 4 of this conclave. It is my privilege to introduce this session speaker, Miss Mousumi Chakraborty, and she is going to talk on use of AI/ML in defense and intelligence community. Ms. Mousumi Chakraborty did her master's degree in electrical engineering from Columbia University, New York, and a bachelor's degree in electronics and communication engineering from NIT, Durgapur, India. Ms. Mousumi Chakraborty has been working for Boeing in the Defense and Intelligence and Analytics division for the past 10 years. Before that, she worked in the telecommunication industry for Alcatel, Lucent, and Hughes Software Systems for 16 years. Before handing over the session to the speaker, I would like to give a few instructions to the participants. I request all the participants mute your audio and video. Chat box will be disabled during the session and enable after the talk. There will be a question answer session after completion of the speaker talk. Those who have doubts can raise their hand or type the question in chat box after the session. Attendance link will be shared in the chat box. Now I hand over the session to Ms. Mousumi Chakraborty. Thank you. Madam, you can proceed with your session.
Okay, let me share my screen.
Yes, ma'am.
Can you see my screen now?
Yes, ma'am.
Okay. So hello, good evening, everybody from Anurag University. Welcome to today's talk on use of AI and ML in defense and intelligence community. But first, I would like to extend my sincere thanks to Dr. Tilottama Goswami for inviting me to speak in front of you and to share my work with you. It's a great honor for me. Okay, so first I want to set the expectations of the talk. Because of the nature of my job and the job restrictions, unfortunately, I cannot share any details of the software applications that I'm using. So I'm going to keep everything very high level, giving you a kind of a 40,000 feet view of the work that we do. So I cannot share the algorithms that we're using, how we are making model, no architecture diagram, no technical details. Instead, I'm going to discuss some use cases or scenarios that we usually handle to give you an idea what kind of work
Ms.
we are doing.
Mousumi, sorry to interrupt you.
Yes.
We are not able to hear you. I guess your microphone setting has changed.
Suddenly?
Can you just check it
Can you hear me now? Can you hear me now?
We can hear you, Rawat sir. It's audible.
Yes, we are able to hear you.
Okay, I will speak
No,
a little bit
still
closer
not
to
coming.
the. I'll speak a little bit closer to the computer.
Maybe it has gone to the some other set. It was showing in the display. Microsoft setting has been changed to some other setting. Can you just go to your audio setting where you can actually check that?
Okay, well.
But sir, it is fine, sir. We are able to hear. Kindly
Sir,
check.
here also it is perfectly okay, sir.
Sir, check from your side, sir.
Yeah, it is perfectly clear, ma.
Yes,
It is very clear, and I think there is no issue in the audio.
Okay, ma'am. You can continue, ma'am.
Okay, shall I continue then?
Yes.
Yeah, you can go ahead, ma'am.
Okay. So yeah, so then I'm going to discuss some use cases and scenarios that will give you an idea of what we are doing in this part of the world. And so once again, we are going to discuss what are we doing and not how are we doing it. A brief introduction about myself. My name is Mousumi Chakraborty. Currently, I work for BIA, Boeing Intelligence and Analytics, which is a subsidiary, a sister concern for Boeing. I'm with Boeing for past 10 years, and we are not involved with airplane manufacturing at all, but we serve the intelligence community with any software solutions and tools that are needed for data analysis. And before Boeing, I was in telecommunication industry for 15 years, working with Alcatel-Lucent, Hughes Software, and UBEST. And I did my master's from Columbia University, New York, USA, and bachelor degree from NIT Durgapur in electronics and communication engineering. So now let's talk a little bit about our clients, which is IC, meaning Intelligent Community. And please do not confuse the word intelligence in IC with intelligence in artificial intelligence. This is different. IC is a group of US government intelligence agencies that conduct intelligence activities to support national security and defense. Examples are like FBI, NSA, DIA, NGA, CIA, etc. There are many agencies like that, and we serve a lot of them. So what do? We have an ecosystem of software where we get vast amount of unstructured data every day from diverse sources, which can be classified or unclassified. Now, this data can be any format. It can be HTML, XML, JSON, PDF, Word document, Excel, any format. And the sources can be anywhere. It can be within the agencies, outside, within the government, outside the country, can be foreign. We get any kind of data. And the amount is also very large, and we store all the data inside. And we convert them to structured data. We have a government mandated format. So whatever format we get, we have to change and convert them to that government mandated format. And then we stamp with classification markings because not everybody can see all the documents. So we have different level of classifications like restricted, secret, top secret, confidential, unclassified. So for example, a person with say confidential clearance should not be able to read any document that are marked with top secret. There are, apart from this classification, there are 20 other classification marking parameters according to government specifications. So we mark the documents with all these classification marking parameters. Now inside a document, each paragraph is marked with that. So there can be combination of this classification marking. So suppose one person who has only confidential clearance is reading a document, and then document has two top secret paragraphs and two unclassed paragraphs. So he will be able to read the unclassed paragraph, but not the top secret because he does not have clearance for that. And those two paragraphs will be redacted. I'm giving you a little bit background before going into AI/ML so that you understand the whole picture. We do content analysis. We enrich the metadata of the document with a lot of important information like classification marking, geospatial coordinates, and you can then use that information later on to point these documents or map this in the map. And then we provide easy retrieval of data, easy like a display of the data and discovery of the data. Like, you know, suppose somebody is trying to find that data, it should be easy enough to find it. And then we alert analysts of any important events. And also one thing I want to mention, by analyst, I mean a person who is working in the agency, like an FBI agent or CIA or DIA agent. So we have started integrating AI and ML into our software to increase efficiency in clients' operation, to take off the cognitive load from the analyst. So suppose an analyst is working on a very time-critical mission where he or she needs to find very important information about that mission from hundreds and thousands of documents. So then he can spend the whole week to read those documents and find relevant information out of it. With AI and ML, then we can speed up this process 1,000 folds. And now analysts can focus on the intelligence analysis part rather than reading part. So our motto is like read less and analyze more. And with automation, we minimize human error as well as we reduce operational cost. So using AI ML gives us a lot of advantages. So we use NLP, natural language processing, to do all this. It does text analytics where like we have automated process of translating large volumes of unstructured text into structured data. We do gap analysis, finding the unknown. The analysts, like, they often say that, I do not know what I'm looking for, but I will know when I see it. So we have to find the unknown and present it to them. And we have to do it in such a way that any non-data scientist can run model, pipeline, train, and test a model easily. We also do like cross-linguistic search, where an analyst will search a term in English and it will find a match result, suppose say in an Arabic document. Okay, so now some little bit of details, like we extract entities from the documents. It automatically classifies key elements from the document text and then identifies whether it's a location or a name of a person or a name of an organization. Now, using entities to search rather than simple text-based search can narrow down our search results and can filter irrelevant data. So I'm giving you an example. One thing I want to mention that these examples are, I came up with some random examples and has nothing to do with any analyst or any agent's work. So say, suppose for an example, an analyst is working on Chinese government's response on COVID and trying to read some document using the search term Xi Jinping for Chinese president and COVID. So if you use the search term and the text-based search, and if you use Qi and COVID, it can match the Roman numeral 11 because that is also written as XI. So if he uses his search term of XI, not using the text-based but saying that I want to find the name entity of XI and text-based search term COVID, then he can narrow down the search result a lot, and he can find his relevant document more easily and quickly. We also normalize entities. So say we are trying to find documents containing USA. So you search for USA, but entity extraction will help us to find all the documents containing U.S, US, U.S. U.S.A, and then United States of America. So all this will be it will find all these places and normalized, and it will say that, okay, you got a match, but it will not include the word us in the search result. It will also handle a misspelling. So suppose an analyst is trying to find out some person, say, and does not know the name properly, how to write the name in foreign language, and entity extraction can suggest close matches. Okay, so into sentiment analysis. We find out sentiments of each entities in the document, if possible. And then we find out the sentiment of the overall document. And then we use that information in our search result as well for faster retrieval of data. So for example, we can search for Trump with positive sentiment only or Trump with negative sentiment only in our documents. Now we measure confidence along with the sentiment so that we control our search result to be more accurate. That means, higher confidence, or to be less accurate, which is lower confidence, and we'll get more results. So we have a kind of a slide bar is asking the clients to move the slide bar to be more accurate or to get large number of documents. So suppose he chooses a 90%, then a 90% confidence, then maybe he will get 2 documents. But if he chooses 20% confidence, he will get, let's say, 100 documents. But many sentiments in there will be like, say, false positive or false negatives. But maybe he doesn't want to lose any document. That's why he is giving his search like that. We also do a sentiment analysis of different languages. We use bag of word approach to do sentiment analysis. So category, we categorize all our documents into a definite set of categories. Example, business, law and government, health, science, etc. is multi-level classification. This also helps us to narrow our search result. For example, we can search for Trump with negative sentiment and in the category of law and government. And we measure confidence and score as well along with the category, so that we can vary our result set. Keyword. So keyword is the most significant phrases in the document. There can be more than 1 keywords in the document. And we store the keywords, we extract the keywords and store those as well. As I said, it can be single word, it can be a phrase, multiple words together. And we measure salience, that is how important it is. So it is a score. We measure that as well. And then with that score, we can control the results. That we can say that I want this particular keyword with a salience score of, say, 90% or 80%. And we vary our result set. Concept, we extract concept as well. Concept is like, topics that are not stated in the text. So you will not find that particular text in the whole document, but it's the main concept, a kind of a topic of the document. So, and then we store it as concept. Example, political philosophy, social institutions, etc. Then we can search using those concepts as well. And we measure salience, how important it is. That is also like a score. And we vary the result accordingly by choosing salience. And please note that I'm not going into any technical details of how we do that, but I'm going to cover what we are doing. So now I'm going to give you some example scenarios. Once again, these are like just I came up with this, has nothing to do with any agent's work. So suppose we are trying to find out documents containing virus in it. So for a text-based search, if you put virus, then we will miss many documents that contains words like Ebola, SARS, Zika, H1N1, but suppose those documents do not contain the word virus in it, it just says Ebola. So then we will miss those documents. So suppose for a text-based search, we need to include virus or Zika or Ebola or SARS, and then an endless list of all the known virus with all alternate spellings as well, so that you capture as many viruses as possible. Also, we need to find the unknown. the new and emergent viruses, the viruses that we have never heard of. So we don't know how to put this. So with the help of AI and ML, we were able to do this task. So suppose an analyst is searching for a virus around, say, December 2019 or early January 2020 timeframe, and then searching for virus, and imagine we find the documents containing COVID. This is the magic of AI/ML. And actually it's happened with us. We were building and training a model for a demo last October 2019. And for some reason, we chose to build a model using this query virus to search for the documents. And our model did alert us very, very early January about documents containing COVID. Okay, another use case scenario. So here we are trying to find out prediction of outbreak of illness in the documents. So outbreak is like, it may not contain the word outbreak as such. And so we cannot use the term outbreak in our search. We really need to read the sentences to find out if it's talking about any outbreak or not. So for example, if there is this like sentence like this, it says 20,000 to 2,000 cases of measles reported in this place. This means an outbreak, and we have to mark it as an outbreak. So with AI/ML, we can do that. Now, another scenario would be the ease of model creation. Remember, the analysts that who are using this they are not data scientists. So it should be very easy to create a new model, to train and test a model using small set of data. And with the simple UI clicks, they should be able to label data and create and train a custom model. And also, they want these models to be reusable with other groups once the model becomes mature, and then maybe there's some approval process, but after approval, one model can be used by another group so that no effort goes to waste. Now, another use case is iterative training. Analysts do not want to spend their valuable time on training a model and labeling a data. So we should be able to train in small batches in iterative process so that they can label the data as they go. We use human in the loop process, leveraging both human and ML to create models with constant feedback and interaction and curation of model by user. And the models use active learning as well, where user will handle low confidence units and feeding those back into the model and make it more mature model. Now, let's talk about some challenges that we are facing. For example, in sentiment analysis. So it's easy to do sentiment analysis on some reviews, say movie review or product review or book review, because reviews usually talk about one kind of like either positive or negative. But it's a little tricky in news format where one paragraph is saying something else, and then the other and the next paragraph is completely negating it and is saying another thing. So it's tricky to do sentiment analysis in our documents. And also it's difficult to handle sarcasm, where a person is saying something to mean completely opposite thing. Example, a teacher is saying to a failing student, "You did excellent, well done." So to capture the sentiment for this kind of sentences is difficult. And we also get a lot of false positive and false negative. We use confidence score to clear those out, but this is one of the problem we face. Now, training and testing models. training is a time consuming and very difficult job, and our clients, the analysts, they don't want to do it, and they want to spend minimum time to train a model. So as I said, it should be done in batches and easy labeling of data. And also it happens that we train a model for something with using one set, and the analysts are using it for completely different set of data. And please also note that not always that analysts are training a model from the comfort of a cozy office. Maybe they are stationed in a battlefield or in a crime scene, and where there is like a very time sensitive thing going on, and they want to perform minimum training and get results as soon as possible. And then we have performance issues. The analysts want to run a lot of documents through a model and get instant results. And sometimes we've seen that it's really slow. We send some documents and it spins and spins waiting for the result to come back and making our clients impatient. So this is just the beginning. The work that we're doing right now is just like we have a lot more work to do in this field. We have text, images, audios, videos, and we want to, get faster retrieval of all this text. NLP is a highly complex interdisciplinary field that is constantly supplied by, fundamental research in linguistics, math, and computer science. So as you can see, we need more research in this field. I would like to encourage all of you to carry on your valuable study and research and achieve remarkable progress so that we can catch the bad guy in no time and make the world a safer place to live. That's all I have for you today. Thank you once again for listening to me, and wish you success in your ongoing studies and research. And then I would like to hand over the control to Dr. Tilottama Goswami. Thank you.
Thank you. Thank you. Yes, she's also here. Dr. Tilottama is also here.
Hello, thank you. It was very insightful, and really we could connect the computer science to the end user purpose. And you also showed us many of those open statements where we can do research. It was very exciting. I can understand because of your job, you cannot really reveal the architecture and all those things, but that's okay. We really wanted to know, as a computer scientist, computer researchers, what is the point of view from the end user. So that's what you have already served our purpose, and we have got and we'll surely strive to do some research on these all those open statements where you have. You can take some questions from the participants. Thank you so much for your time, taking time from your valuable, I know you have office days is going on, but a few questions please take, and thank you so much.
Thank you, Dr. Tilottama. Now we will take a few questions. A participant have already raised the hand. Srilata, can you unmute yourself and?
Yes, sir. Thank you, sir.
Yeah.
Thank you so much. I'm hello, Mousumi ma'am. I'm Srilata from Srinidhi Institute of Science and Technology in Hyderabad.
Hi, Srilata.
Hi, ma'am. And I was extremely impressed by the presentation that you have given, and you have also covered many of the insights into how the NLP can be used in terms of sentiment analysis and its methods. But I would like you to shed some light on what type of techniques we can use in terms of ML and NLP.
That's the thing I cannot share, like what we are using. And see, we are not a research company. We we get a problem and we work on it and we try to get a solution as soon as possible. So I know what we are using for NLP, but I cannot share the technique that we are using.
Ma'am, any algorithms that you can?
No, I can't. Unfortunately, I'm so sorry. I cannot share the
Yeah.
algorithms that we are using.
Yeah, I think she had already told in the very
ma'am.
beginning because of those things. So we respect that. Yeah. So I think we should not ask about those questions where we are
If you
talking.
want to know more about NLP and deep neural network, you can take courses from Coursera. There is this deep learning university by Dr. Andrew Ng. I have big respect for him, and it's like very nice courses, very good hands-on work assignments. So those courses are very good. You can take those from Coursera to learn about NLP and deep neural network.
Yes. Thank you, Mousumi.
Thank you, ma'am.
Can you just take few questions from the chat window, Ms. Mousumi? There are few questions. Maybe you can
Okay.
select some questions in the chat window.
I cannot see the chat window. Where is the chat window?
Chat window. Okay. One of the questions says, how can we relate NLP with the cloud security?
Okay, for us, we do use cloud, and we have software hosted on clouds, but we use government cloud. We call it Gov Cloud. It's not public cloud, and we have special security inbuilt into that. So when we use NLP from application standpoint, we don't have to take any special measure for that using hosting a application on cloud.
Great, thank you. There is another question from Dr. J. Srinivas. The question goes like this: can you explain about effectiveness of pre-trained models? Effectiveness of pre-trained models, yes.
Yeah, we are using that, a pre-trained model, and actually it's trained on something else, and we are using for something else. And of course, it's sometimes it's not that effective, and that is one of our challenge. So we are kind of working on it. Yeah, it's not that effective for us right now. If the data set is different, and if the data set is same, then it's okay, good.
Okay, so now I think we will take one last question. The last question is, we have a, does training a model mean the same thing as testing a model?
No, training a model will not mean the same as testing a model. It's too different, and different data set can be used for that, or same data. Yeah, I think different data set should be used for that.
Thank you very much, Ms. Mousumi. Now I request my colleague to show that appreciation certificate. We will be sending this appreciation certificate to our resource person, Ms. Mousumi.
Madam, can you stop sharing your scene so that I can share my scene?
I did.
She has stopped already. Can you just check it? Yes. So,
thank you very much.
Thank you very much. And let me put a vote of thanks. So thank you very much, Ms. Mousumi, for today's session. Your talk about sentiment analysis, classification, you talk about keyword and concept, and especially you talked about the various use cases that are currently being developed using AI and ML. And I'm sure that participant researcher will definitely get benefited from your wonderful talk. Thank you very much, Ms. Mousumi. Have a nice day. Thank you, everyone.
Thank you,
now, yeah, so now I think when our next session is going to start?
Sir, actually, next speaker has already joined.
Great.
Mr. Soumen has joined from Australia, Queensland. Great. Just now he confirmed. So I think another 5 minutes we can start.
Yes, yes, that will be great. Yeah, we can start it.
Yeah. Yes.
So team, can we make him co-host? Dr. Soumen, can you just check it? Yeah, so you have already made him.
Soumen Ghosh, yeah.
Soumen Ghosh, yeah. Soumen Ghosh, yeah.
I think it is okay for me also. Can you hear me and see me?
Yes, we can hear you, sir. Yeah.
Okay.
Hello.
So right now I'm just stopping the video. Later.
Yes, Madhu ma'am, you can maybe proceed with that presentation.
Yes, sir. Yes. Deepika ma'am, can you make Vijoti ma'am as the coach,
Okay, ma'am.
as she is the co-chair for this?
Okay, ma'am. I think before she didn't join.
Okay.
Well, okay. Amanda is joined.
Yeah.
Ma'am, you can display the flyer, the speaker.
Yes, ma'am. Deepika ma'am will be
Vijoti
displaying.
ma'am has joined, ma'am. May I
Okay.
first?
Okay. I request co-chair to just share the flyer.
Madam, ma'am,
Yeah.
flyer has been shared. You can proceed.
Yeah. Shall I proceed with the session now?
Yeah.
Yeah. Okay. Fine. Good evening, everyone. This is Madhavi, Associate Professor from Anurag University. And I welcome you all for the last session of this day 2. And the resource person for this session is Mr. Soumen Ghosh from Australia, University of Queensland. And the topic for today's session is machine learning approaches and the diagnosis of patients with focal epilepsy. And I take the privilege to introduce our speaker for the session, Mr. Soumen Ghosh. Mr. Soumen Ghosh is a graduate student at the prestigious University of Queensland, pursuing his research in the field of machine learning with focused application in machine medical imaging. He is also a visiting researcher at the Royal Brisbane and Women's Hospital. Prior to his Australian stint, Soumen completed his bachelor's in computer application from West Bengal University of Technology. He has a double master's degree in computer application and information technology from West Bengal University of Technology and University of Hyderabad. Soumen has won several awards and scholarships, including GATE and Springer Student Award at the International Conference on Patent Registrations. Apart from being an excellent academician, Soumen has also excelled in research, undertaking several projects at different prestigious institutions in India, and has also authored several articles on artificial intelligence and machine learning. Soumen is quite proficient in teaching as well as several programming languages. Now, Soumen is currently working under the supervision of world renowned expert in epilepsy, Professor David Reitens, having won the extremely competitive scholarship from the Center of Information Innovation in Biomedical Imaging Technology at the University of Queensland. And welcome, sir. I would like to welcome you for the session. And I request the speaker to take over the session, sir. Thank you.
Thank you very much for the nice introduction.
Welcome, sir.
So first I want to thank everyone, those who are behind this great job. Sorry for the technical problem. Okay, so it is a great honor for me to be here today, and I want to thank everyone, those who are organizing this great event, and also
Sorry,
I want
you. Have you shared your screen, sir?
Yeah, I'll share.
Yeah.
And also I want to thank Professor Tilottama Goswami for inviting me to share my experience. So I'll talk about the machine learning applications. Just a minute, I just set up everything. Okay. So my talk about machine learning approaches in the diagnosis of patient with focal epilepsy. So focal epilepsy means epilepsy is a disease. It is a neurological disease, and focal epilepsy is a special type of epilepsy. So before I go into my talk, I just want to thank my supervisor. So I started my research career from University of Hyderabad. That was a great experience. So in University of Hyderabad, I worked in the area of RAPSET. So the aim of this project, like to proposed dimensionality reduction approaches using RAPSET. So later I shifted to TIIT, where I worked under Sinassis Mukherjee and remotely co-supervised by Dipti Prasad Mukherjee from ISI Kolkata. And there I work in the area of machine learning and deep learning, particularly applied in sport video analytics. And currently I'm working in Queensland University. So here my area is focused on medical image analysis. Particularly in my PhD, I'm working for epilepsy disease. So before I start my presentation, I just want to share one small video, 2 minutes video. There you can get little idea about the epilepsy disease, and that news was came like two years before, and that is the news that is of our lab work that is published. So just I'm starting the video just for 2 minutes.
Life-changing surgery is helping thousands of patients living with epilepsy. Now, a leading team from the Royal Brisbane and Women's Hospital is giving more Queenslanders the chance to be seizure-free.
For 33-year-old Josh Marks, this routine checkup is a milestone. It's a year since epilepsy surgery turned his life around.
It literally took over everything I could do on a weekly basis.
Josh endured regular seizures after having his first one out of the blue 5 years ago. It cost him his driver's licence and his independence.
It was very traumatic for the people that were around me.
Desperate for a normal life, he underwent surgery through Queensland's only epilepsy clinic at the Royal Brisbane and Women's Hospital.
Well, until a few years ago, people routinely had to go to Melbourne or Sydney.
Already, the RBWH team has performed 60 operations. A new $4 million state government investment will significantly boost treatment.
We will have high-level surgery that will be available to more Queenslanders than ever before.
The real difference is that we have a long waiting list, and now we'll be able to get through that waiting list.
Another plus, allowing patients to have support close to home at such a critical time, something Wally Lewis knows about after having his surgery done interstate.
Anybody that's dealing with post-surgery problems needs to have plenty of their family and friends around. They've got to have it 24/7.
While 70% of epilepsy sufferers can control their seizures with medication, about 30% cannot. That's why brain surgery can be a potential life changer.
We find that people who were having, seizures every day, every week, are becoming completely seizure-free.
Like Josh, who's now expecting his first child with his wife Sarah, he's even reapplying for his licence.
Being able to see Josh come ahead in leaps and bounds, it's just everything that a father wants to see.
Couldn't be happier.
Eva Milik, 9 News.
So my talk will go like I'll explain some background of AI and some fundamentals, and after that I'll explain how we are applying machine learning techniques to the medical domain. Especially my focus on to develop some machine learning and deep learning techniques which can help to the doctors to do the epilepsy surgery. So like AI, we know the famous scientist Alan Turing. So the journey of AI started like 1947. So that time he thought like he come up with a question. So that is what we want is a machine that can learn from experience. So that idea came. It is like more than 100. So it is huge. Last 10 years, we are seeing the progress of the machine learning and deep learning. So it's take a lot of time. So, in the field of computer science, Turing Award is the biggest achievement. So in 2018, first time machine learning and deep learning got recognized by Turing Award. So you can say it is the journey from 1947 to 2028 to get the recognition. So a little background of AI. So like AI basically simulating the human intelligence to the machine by doing some coding or some stuff. So that is the idea. So doing the mimicry of the human activity, human intelligence. So that is the basic idea of intelligence. So we know nowadays everywhere, wherever we are seeing AI is applied everywhere. And just slowly I'll go to the machine learning and I'll go to the problem. So regularly means like we are using it is too much that we are not able to recognize which one is like AI based and not. So like few applications like email filtering. So when this one is very means regularly we are seeing that one. So when email is coming, so it is basically it is classified in 3 parts. So whatever the like important or like relevant emails we are getting in the primary social. So that is a application of machine learning. So it's the application of classification and smart reply. Nowadays you can see if you in the email also or the chat box also you will get the option of smart reply like thank you or anything many. So that is the application of AI. And so many. So Google predictive search. So product recommendation. Of course, if you search any in Amazon or everywhere, you will get the similar kind of or many things. Not only the similar kind of. It will find the pattern of many hidden things. And like Alexa, Siri. So we know all the things. Smart keyboard. So many applications we are seeing nowadays. Video, of course, this is very popular video. So now I don't think nowadays means anyone is typing in the YouTube. Mostly whatever we are watching, that is already recommended by the YouTube. So that much intelligence came. But we in AI we have some limitation. So like the limitation is like first limitation is mostly on the we need a lot of data. That is the first problem. Second problem is like it is a black box. Black box means we are not able to interpret the intermediate things. So that is why we are calling it is black box. And still, like means like AI struggling to understand the humor, sarcasm, all the things. And there is a big problem with bias. So like in the AI model, there's a lot of human biased are coming because we are preparing the data, we are annotating the data. So automatically biasness is coming. So a few other limitations also there. So whenever we will implement, we have to take care of all those things. So again, Alan Turing, so the famous mathematician as well as computer scientist. Those who don't know, they can see one movie, The Imitation Game. There we can see his journey, but that movie will explain about his like not about any machine learning things. There, his role is to as a cryptanalysis to break some code. And so Alan Turing proposed a test called Turing test, which will decide the intelligence of the machine. Means like we are demanding a machine is intelligent, but how much intelligent we will decide. So to decide that, Alan Turing proposed a approach called Turing test. Turing test, how we if we demand one system is like intelligent enough for a particular skill, so we'll put that computer to one room and similar or one human to another room, and one like one interviewer will ask set of questions, same set of questions to the computer as well as the human, but he or she don't know which one is computer and which one is human. So after asking the set of questions, if that integrator is able to understand, not able to understand which one is computer and which one is human, that means that system is really intelligent. Then we can say it is a intelligent system. So that is why nowadays you can heard about many news. Okay, AI achieve that one, AI win that competition. So it is not mean that it is just competing with human, and it is the exam for them to prove they are intelligent enough. So that is why that comparison is required. So the journey of AI started. So the journey of computer and AI started. It is long back, 1642, and slowly came in 1952. Alan Turing proposed this test, and in 1955 AI term tokenized, and so many. So first time we seen 2002 one robot. First time one automated robot was like built, which can clean the house automatically. Means it will move around your floor, and if some obstacle will be there, it will understand and it will take the move based on that. And similarly, it is means so many other improvements, and slowly it is achieved. And 2014 and Goodflow come with a new model which is called GAN, and that is a great groundbreaking idea, which has currently the GAN is applying hugely in different domain. And later 2016 AI on the Go game, and so the Lee Sedol is the world best Go player, and AI lose him. So that is a good achievement of AI. And currently in 2018 or 19 now currently, so we can see everywhere, every engineering colleges, everywhere actually, wherever computer, non-computer science, they are studying about the AI. So AI reached that much level. So now I'll go little fundamentals. So this is the basic idea of machine learning. So this is the traditional computing, and this is the machine learning computing. What is the difference? In traditional computing, we give the data and we give the logic, means program. We write the logic manually. Based on that logic, means that program will utilize that data and it will give the output. But when the data is too complicated and we need to know the many hidden feature, it is very difficult to write such code. So the machine learning will do the opposite thing. Machine learning will take the data and the corresponding target or output. If we have the huge number of data, sufficient number of data, we can train a machine that can learn the pattern, that can learn the mapping between the data and output. So when it will train, means when the machine will learn the mapping, so after that, that rule will be generated. That rule we can use for unknown data, unseen data. So suppose new data came for whom we don't know what is the output. So we can apply that. We can apply that rules on that, and we can get the output. So it is a simple example of that. So like we have a brain MRI and we have the corresponding tumor. If we give such type of data to the computer, it will learn the pattern. That pattern, that weights, anything we can say, we will use in future for unseen data. So like we have that image, but we don't know which area is like tumor exists. So if we test with that data, that machine can able to identify the location. That is the idea of the classical machine learning. So classical machine learning have few like algorithms for classification, regression, many things. So support vector machine is one of them. So we all know. So like the idea is like two-class classification. It is two-class classification problem, and like which like linear classifier can do the best classification. So like we have to do the margin. So for like any line can classify, but we have to find the best. So this is a great idea. And one in SVM we use kernel trick. That is a really extraordinary idea. So what is the idea? Like we have a one dimension data, like suppose -5 to +5, and 0, 1, 2. That three are one class, and all other are different class. So if we want to do the classification, we need a circle. Circle means it is a not linear, non-linear classification. But if we add another feature with that, so like this is X dimension, this is Y. Y means it is X square, suppose. So so after that, so like that dimension we added. After that data we can do the means classify using linear classifier. So idea is that, so some data is there. So if the data is currently not classifiable using linear classifier, maybe in some higher dimension it is possible to classify using linear classifier. So similar example, suppose this is 2D data. If we want to classify, we need a nonlinear classifier. But again, if we increase the feature, we can do the classifier. Another idea is called one class classification. One class classification, it is means in first look we can people can think it is like a similar like binary classification, but not exactly. It is many difference are there. So the idea is like one class classification means the model only understand one kind of data. It will learn for only one type of data. All other data, it can be anything, it is like unknown for the model, and it will say it is an outlier. So like if I train using one class, so all the so using that data, it will make a sphere, and whatever the non-similar data, it will come as an outlier. So same thing again. So it is looking like a non-linear classification, but again it is a SVM, so it will use the kernel trick, and in some hyperspace, means in some higher dimension, it will classify as actually linear classifier. And we know about neural network, that is also one basic machine learning algorithms we can use for classification or regression, anything. So, but what is, so that is the input layer and that is the output. So input layer, so like how we use that machine learning algorithm, classical algorithm, we don't use directly, means like we don't give raw data directly to the model. So we take the raw data, we extract the feature. So who extract the feature? Human are extracting the features, and that features we are giving to the networking. So that is one biasness. Because human are, so it is human biased, we can say. So to overcome that, and another thing, so, and we have to decide the dimension. So that is, a dimension is a means it is the number of feature, means the dimension of the feature is play a crucial role in the model performance. So we have to decide the dimension also. So like we know curves of dimensionality, if we increase the dimension, so suppose we have one feature X, and we have 5 instances. If we increase the one feature, such space will increase by means from 5 to 55, because it is a cross product. So A and B, if 3, then it will be cross product, then it is 3, 9. So it is 5, 5, 25. Again, it is like if we add one another feature, then it will 125. So what is either? So means if you increase the feature, so like it is exponentially growing the search space. Search space means from where you are searching the solution actually. So if we increase the feature, means like how we'll decide which is the optimal size of the feature. So when we increase the feature, initially model performance will increase, and after sometimes it will decrease. So we have to come nearby that. So it is not like any generalized idea. It is based on the problem, based on algorithms. So for different problems, that threshold, that area is different. So that you have to take care by doing the experiments. So how we can process image data using neural network. So if we want to use the neural network, then what we have to do, we have to, it is a 2D image, we have to stretch it in a 1D format, and we have to use. Then, but how, means like, what is the problem if we do like that? Then simple problem is, it is a huge dimension. If it is 10 by 10 image, if we stretch it will be 100. Then it is a huge dimension. So it is suppose 100 by 100 image. Then it is, so it is difficult. And another problem if we stretch it in one dimension, then the model not able to take care the spatial information or like local information, because from 2D we'll go to 1D. Then what is the solution? Solution is like CNN. No need to like stretch it in 1D and after that you misuse it. So directly we can use the image. That is a basic model of CNN. This is an example of CNN architecture. Directly we can pass the image, and using some convolution operation, max pooling, activation function, we can do the things. So then what is the difference between the machine learning and deep learning? So in deep learning, we can say deep learning is reducing little more human biases. Why? Because this feature extraction process is taken care by the network itself. So we are giving directly the raw image to the network, and we are getting the output. So little advancement in DL. So that is little background I explained. Now I will go in AI in healthcare, how AI applied in healthcare. So when we are going for healthcare, we have to, means it is like a lot of ethical things. You have to take care many things before doing the experiment or anything. So how will you get the data? You have to collect the data from hospital, from the like clinic, and from that data you have to do, means like you have to organize. That is all our unstructured data. It is not like it is organized, given the MRI image corresponding ground truth, it won't be like that. And not in, and in the real life, what is the problem? Suppose you are collecting data from hospital. So you are collecting last 10-year data from hospital. So suppose in MRI, so in last 10 years, that the MRI technology also changed. Suppose initially it is used 1.5 Tesla, now it is using 3 Tesla. So different modality also coming. So how you are like comparing this data? So a lot of other challenges are there. So anyhow, you have to collect the data from the hospital. After that, you have to do pre-process, you have to do many stuff, and finally the AI model you will build. After that, whatever result you will get, that is the most time consuming process. You have to consult with doctors or the clinical person, and you have to that is a bi-directional process. Like they will give some means ask for some verification you have to do. So when they will confirm okay, then you can whatever findings you got, you can update, and then that model can be applied. So this is some survey. So recently, like AI applied in many domains. So mostly applied in oncology, like cancer risk things, and neurology also in second most. So my area is like neurology. And all the publication, so they mostly use structured data, structured clinical data. So that is also one challenge. But we are using unstructured image data, as well as some genomic data we are using in our project. So we can see some example like this is a bottleneck deep learning architecture. It is they are calling it is they proposed, and they calling it is CNet. So that they train the model using different kind of images. So lung images, retina images, and it is predicting properly. So because that model was trained using huge image, annotated image. So it is and that if you know the UNet, it is the similar structure of UNet. So it is an application of deep learning in medical domain. Another application now people are focusing on end-to-end, if we want to diagnosis tumor means brain tumor diagnosis. So if we take the cell, so in laboratory normally if we go the traditional process, it will take 30 minutes. But machine learning approach using all means end-to-end from the image to final, it is doing in 2.5 minutes. So that type of things are people are using machine learning for that type of application. Also people are using so another thing like scalability. So now also people are trying to make scalable deep learning model. So that is also simple classification, but they train the model using huge data, so and huge number of classes. So they train that model for skin cancer. So many type of research going on currently. So I'll explain a little bit about epilepsy before I show how we are using machine learning for the epilepsy diagnosis. So epilepsy is the most common neurological disorder. So it is epilepsy affect about 1 in every 26 people. 65 million people in the world currently living with epilepsy, and it is the most common neurological disorder often observed in children. And also it is like in any age, any gender, it will. So what is the problem with epilepsy? So how we'll know means how we'll characterize epilepsy? Epilepsy will characterized by seizure. Seizure means it is a temporary disruption of your brain function. So suddenly like brain function will stop working, and it can be anything like how you'll like it can be you senseless, or like it can jerk your hands and legs. Many things can happen. So epilepsy so what is the treatment for epilepsy patient? So treatment is like whenever seizure is confirmed, like from clinic, whenever seizure is confirmed first, and they will check if there is a recurrent chance of seizure or not. If there is a chance, they will start medication. So means it is called anti-epileptic drugs. So on an average, 70% of patient out of 100, 70% of patient will recover using the anti-epileptic drugs. But 30%, in average, 30% patient, they are not able to recover. So that is called drug resistance epilepsy. So for that, for them, what is the option? For them, option is surgery or like some vagus nerve stimulation or deep brain stimulation. So how? So like means like based on the seizure onset, means like if it is focal means like a small part of a brain, then we can do the surgery. Surgery means surgery resection, means that part will like cut, and that will like that won't be like that area will resect. And if it is generalized means like it is like spread throughout the brain, so then you can't do the resection. So surgery only possible when the seizure onset is focal, means in a local part. So that is called focal epilepsy or focal seizure. So, and another thing, so but during this period of medication or surgery, so it is like it will take if surgery is there, means if epilepsy is there, in the best case also it will take 4 to 5 years to recover from that. So by the time people are trying to predict the seizure, means like when so if we came to know like when seizure will occur, so like it will make little easier for the patient. So based on EEG data, many paper published already. Also many technology build, also like some smart watcher like thing came that can predict the seizure. So like when seizure will occur, that can. So using like EEG data, it is like it is the like brain signal. So it is like time series data basically. So that data is used like multi-layer perceptron and predict like preictal and ictal. Preictal like means like this area means like now seizure will come after sometimes, and so and the interictal means like it is on the safe zone. So that type of work done, many people did that type of work. So that model also improved a lot. Initially they directly use the mesh, like neural network. Later they add deep neural network, and later they realize like it is a time series data, then we can use the LSTM also. So like that, so many things came. So means like a lot of work done in that area. So for surgery, we need to know the location before surgery. So like it is not like directly someone will cut the brain and do the operation. So for that we need the MRI image. So MRI image also have different qualities. So like 1.5 Tesla, 3 Tesla, 7 Tesla. So that is like 1.5 Tesla means like less power. So it is like not that much clear image. 3 Tesla is average, 7 Tesla. So still in the clinic, in the hospital, 1.5 Tesla or 3 Tesla maximum they are using. 7 Tesla not really using in the hospital right now. Maybe very few hospitals are using, but in academy for research purpose they are using. Right now we are using 7 Tesla MRI. So like why this like change is required? Because if we want to find some lesion, it is very difficult here, but it is very prominent here. So like so like how much it is good, it will use for like it will like have good impact on surgery, because we can localize more properly. So the FCD means like the focal cortical dysplasia. Focal cortical dysplasia is the like, so FCD is the malformation of cortical brain development, which is the most common cause of drug resistance epilepsy. So drug resistance epilepsy is the effect, and the cause is FCD. Means FCD means like some part of the brain is affected. So that part we have to identify. How? So currently how it will do. So we have some MRI scan and some radiological features based on the medical studies, like the medical committee, they decided some standard, and based on that feature they are localizing the area, which area. So they given some feature like focal cortical thickening. So like, so this is called cortex. So that is like abnormal signal intensity, cortical thickening. That cortex is little thicker than the other. So, but it is very difficult. It is very difficult to localize. That is so our sorry. So our work is focused on use machine learning based approach to localize that area automatically without like intervention of any human. So how we can do? So normally we can use machine learning approaches, supervised approaches to do that. So that is by first look we can see it is a segmentation problem. But so like this is a supervised deep learning model we can use for like segmentation. So this is a brain MRI and the corresponding the annotated data, means ground truth. So that ground truth, some medical expert did that one, and that we need means like a huge number of that type of paired data we require to train the model. So then only we can use the supervised learning. Then that is a problem, means like in real world we can't use always we can't use the supervised learning. So what is the challenges? Like sufficient number of data for training the machine learning model, it's not available. Huge number of human experts are required. So suppose if we want to do the like if we want to use the machine learning supervised learning approach for FCD detection, we have to annotate lot of MRI scan. So for that we need like huge number of radiologists. That is really impossible. And also if you got the human expert also, so identification of subtle lesion in MRI, so that small lesion not always possible to identify. That is also another challenge. And if we do the annotation, then there is a huge chance of human biases, and of course it is a time consuming process. So these are all the challenges. So we can't use supervised really in this problem. So how we are using? So we are using, we are thinking for outlier detection approach. Means like we are segmented the brain and we are trying to find which part of the brain is not normal. That is the idea. So for that we use one class classification algorithm. So like if that type means we segmented that brain like a small pieces, and we plotted, we given to the one class classifier, one class SVM. So then the classifier will like identify this abnormal brain segment as an outlier. That is the idea. But how we can give directly? We can't give the images. So for that we need a dimensionality reduction. So for that we use simple autoencoder. It is unsupervised dimensional reduction approach. What is the idea? We are trying to regenerate the same image. So when the machine trained properly, this autoencoder will train properly. So that compressed representation of the image is capable enough to generate the same image. Means no need to use the whole image. You can use only that small feature. That feature we are extracted from there, and we send it to the one class classifier. So currently we are using this data. So currently my model is working trained on 30 healthy brain, and we are tested in 12 patient brain. And that is 3T and 70 MRI is available. So both the data I am trying. And in future, what I am trying, currently I am actually gathering data, acquiring data. So two type of data. Imaging genomics means I am acquiring image as well as genomic data, because for epilepsy, it is like established that many gene mutation also like responsible for this disease. So we are trying to find the relation between the MRI and the gene. So like 70 MRI and genomic data we are collecting from 80% and 40 healthy. So that is on the process. Around 1 year it will take. And also for drug resistant epilepsy, I am collecting another data set. That is, I'll collect the last 10 years of epilepsy patient data from the hospital. And that data, so that is challenges like multimodal data you will get 1 Tesla, 1.5 Tesla, 3 Tesla data, and medical findings, that is also different. So that type of data we have to collect. Means I'm right now I'm collecting that type of data for my work. And that is my proposed model. Directly we are giving the means we are scanning, and we are sending this MRI scan to a autoencoder. From that autoencoder, we are extracting the feature. We are giving to a one class SVM, and that SVM is just finding the outlier. And based on that result, we are generating a heat map. Heat map means that area is affected in the brain. So how we are doing? This is the brain MRI. We are splitting in different segment that way. And from that patches also, if you see some black patches, means some background, we fix some threshold, and we selected some patches. We remove all those background patches, and rest of the patches we use for the training the model. So that is the result of the autoencoder. So that is original patches, and that is regenerated patches. And the extracted features we are sending to the one class classification algorithm to find the outlier. And finally, this is the input of my model, and this is the output of the model. So like this area is like model spherically, this area is not normal. So we can understand that. So I just overlap that two image to understand the reason. So that result is just an initial result of my model. So we have to improve a lot, because if we resect that part of the brain, then so many functions will be off. So it is not possible. So we are trying to improve. We are trying to use different modality of the MRI sequences. Means like when we ask for MRI scan to an epilepsy patient, so like 10 sequences, means T1, T2, different kind of MRI scan. So we are trying to use all the different kind of scan for finding more relevant information. And also we are trying to improve the model. And in future, we also trying to add some genomic information to localize the FCD lesion. With that, I'll conclude. I'll happy to answer any questions.
Thank you, sir. Thank you so much. And now the session is open for questions. And the chat will be enabled. And if the participant want to ask the question, they can kindly raise their hand.
Very good evening, sir. Myself, Dr. Narendra Singh from Anurag University.
Hello.
Sir, very good to see that about the research work on epilepsy. Similar work has been done from my side also, like predicting of cerebral palsy disease with the seizure levels and epilepsies.
Seizure levels, okay, means like it is kind of seizure prediction.
Yes, seizure prediction for cerebral palsy patients.
Okay, okay, nice to.
Yes, sir. But we have means when we are doing this research, we means actually we would like to design a gadget kind of thing for the people of cerebral palsy patient.
Okay.
Like we are finding the difficulty, like when we are recording the signals, the artifact signals which are being recorded through EEG. When we are composing it to actual data, from raw data to actual data for prediction of this disease or for the cerebral palsy, we are losing some of the data which is very important when we are converting it to the to actual data for machine learning and AI purpose. So even though we are using ICA and PCA components for filtering the data, some of the data is being lost. So can I know, is there any kind of methodology that when we are converting the data from raw data to the actual, data which is required for a data set, is there any simple methodology that we can convert the data from this raw data to the actual data set?
So like I'm not using EEG data, but I got your question. So like for MRI data, how we will do? So when we will scan the data, we will get like decom means like format. So decom format means in that data we will get like means like all the information will be there, like patient information, but we convert that data to the Nifty format. That is little more easier to understand. Then also we lose many information, and from that Nifty format we do the processing. But we can't like convert in the real like JPG or like that. So I don't know how much you are like doing the filtering or like pre-processing, but you have to try as less as you will do the like pre-processing. Means my means is like you try to utilize more raw data, how much it is maximum possible. I particularly I'm using EEG, so I'm not getting the sense maybe.
Yes, sir. Actually, the waveforms which we get from the patient when we are recording that, at the time of recording the patient, actually the CP patients will commonly moving out their legs and head. And sometimes if we give some tablets like sleepy dose tablets, and if we are collecting the brain signals, that both the data, which is making like we could not classify the real-time data and the sleep collected data. So we are facing some problem in that area. So thought of can give some suggestion.
Yeah, so you can mail me. I particularly I'm not working, but I know a few persons they are working, so I can discuss with them. Maybe I can help you.
Okay, sir. Thank you, sir.
Thank you, sir. Sir, there are some questions in the chat box. I would like to read it for you. So the questions in the chat box are: how to implement machine learning model for health risk prediction? That was a question asked by Ashutosh Patel.
Health risks prediction. that is a huge question. Huge question means like health risks means like risks can be anything. It can be heart attack, it can be neurological disease. So like if it is too specific, then it is easy to understand. Otherwise, how means like for we need the domain specific, because otherwise how you will train the machine. Means machine learning means you have to train the machine, you need the data for that. whatever you want to do, you need the data for that. That is the experience for the model. So health risks means for particular domain, suppose for epilepsy disease, neurological disease.
I think he has mentioned chronic disease. Any chronic disease for this one?
Like which machine algorithms are useful for chronic disease prediction?
That way it is very difficult to say, but like I'll suggest like means first you have to like analyze the data, what data you have. So based on like if it is image data, then you have to think for some approach. If you have some like numerical data, like algorithms are fixed. We are not using some new algorithms. We are using some SVM or some decision tree or some deep learning model, autoencoder, simple. Everyone is using that only. But how you are formulating the problem, that is the challenge. Means we are not using some new algorithm. Some algorithm we are using, but from the data, how we are projecting the problem. How I explain. If we like use the supervised algorithm, if we want to use the supervised, then we need the image corresponding ground truth. But in all the field, it is not available. So then how we can do? So we are thinking that way. So that way we have to think. So it is like there is no generalized answer. So what is the problem? Means what is the issue, and like how much data you can gather related to that, then only you can think how to address.
Okay, thank you, sir. One more question. How to predict matching scores of thermal images?
I don't think it is like
We do understand. I think some of the questions are coming maybe in a different this one.
Yeah.
It's okay, sir. Yeah, it's okay. I think I would request the participant to, they can write a mail to him anytime. And
if have someone problem regarding the neurological disease or something like then they can write me. I'll try to answer. I'll try.
Okay, now I request the co-chair to display the certificate of appreciation. Soumen sir, as a token of gratitude from our side, we would like to display the certificate of appreciation.
I'll stop sharing.
Yes, sir.
I think I stopped. Yeah.
Yeah. Thank you, sir. Now I request the co-chair to display the certificate of appreciation. Vijayati ma'am.
Thank you. Thank you very much.
Thank you, sir. Now I take the privilege to give the word of thanks for the final session of the day. And thank you very much, sir, for spending your valuable time with us and enlightening us with the topics on AI, machine learning, SVM, and neural networks. And you have given an insight about artificial intelligence and in healthcare, and how you're going to come up with brain tumor diagnosis, and how you're going to use the classification algorithm to represent the skin care, how we are going to use to find out that, and outlay detection, how this could be used on finding out the epilepsy. Sir, we are very thankful to you that you have thrown light on different topics of this machine learning along with artificial intelligence. And I thank every participant in this one for patiently listening at this moment also. And I thank everyone to be available at that moment. Thank you so much, sir, for being over here with us.
Happy to
Thank
answer.
you.
Thank you. Please send me mail if you have some doubt on that.
Sure. Thank you.
Thank you, Mr.
Thank
Ghosh.
you.
Yeah,
Thank you,
very
Soumen.
Thank you, sir.
Now we will meet tomorrow. What time?
Tomorrow.
Tomorrow 10 o'clock.
So 10 o'clock session.
Yeah. Good night, everyone.
Good night, sir. Thank you so much
Good
for
night,
being.
sir. Good night, ma'am.
Thank you.
All the participants are requested to fill the attendance link. It will be open for another 15 minutes.
Yeah.
Thank you. God bless you from Nigeria.
Thank you. Thank you.
Thank you so much. Thank you.
शर्म नहीं आती मारने के लिए? बड़ा हो गया